Good day, and welcome to the Plant Engineering Webcast, Accelerate Time to Value with Smart Factory Solutions in the Cloud, sponsored by Amazon Web Services. I'm the moderator, Kevin Parker, and I'm happy to join you today on behalf of Plant Engineering. Here are some tips to help you get the most from today's webcast. If you experience issues with your slides or audio, refresh the browser or click the Refresh Media button under the presenter's picture. Control the volume of this webcast by adjusting the volume on your computer or on the webcast platform. If you have technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for the speaker in the Ask a Question box on the left-hand side of the screen as well. The Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion, a PDF copy of the presentation, and other resources, use the Event Resources tab on the left-hand side of the screen. Those documents will also be available with the on-demand version of this webcast. I'd now like to introduce today's presenter, Joseph Rosing. Joe leads the AWS Manufacturing Solutions Strategy and Portfolio with a focus on delivering solutions through AWS services and partners to accelerate growth, reduce costs, and drive innovation for industrial manufacturing customers. He has experience applying machine learning to manufacturing applications and integrating new technologies into the plant operating rhythm and culture. Prior to AWS, Joe spent 2 years at a machine learning startup, following more than 10 years at Rockwell Automation, with roles in product management and operations leadership. Joe, welcome to today's webcast. The floor is yours.
All right, thank you, Kevin. Appreciate the introduction. So in today's webcast, we're going to cover a few key topics related to how we can accelerate smart factory deployment using the cloud. We'll start going through a few industry trends and challenges, and then talk specifically about how we can enable the smart factory with the cloud. And then in the end, we'll go through a handful of examples of solutions and talk briefly about how to get started. Now, across industrial manufacturing, the overarching trends center around how to leverage ever-increasing amounts of data to enable new capabilities. And we hear a lot about Industry 4.0, digital transformation, IoT, etc. But put simply, it's all about how we enable new capabilities with data. And so here we summarize these capabilities into 4 categories. The first is digital manufacturing, basically using data to create a cyber-physical system that improves manufacturing execution with better decision-making, some level of self-correction, transparency, and a flywheel of cost productivity. Second is product as a service. Here we're using data to create new business models and revenue streams that redefine how customers engage with our products and drive additional profitable value. Third is connected products. Here we're using data to better understand customer behavior, create the next generation of products, and ultimately we want to redefine the customer experience for additional differentiation. And then finally is sustainability, a common hot topic, and as manufacturers are typically leading consumers of energy, how can we use data to be more energy efficient and reduce waste, all in an effort to both reduce operating costs as well as be environmentally conscious. Now, as we look at data at the center of these trends, that data needs to be available within a system that touches all aspects of the operation. As a result, data becomes a driver of a flywheel that increases value and continuous improvement for the entire system, be it in product or process design, the factory, or the product itself. So let's take a look at this flywheel a little bit deeper. You can start at really any of these locations, but again, data is the driver. For example, today we're going to primarily focus on smart manufacturing use cases within the factory, such as how to make production more efficient, improve quality yields, and improve machine availability. But once the product is shipped, the production data can be used in the field also to track product lifecycle management and traceability beyond a simple date code that many use today. Additional data can then be collected in the field so that you can understand how your products are being used and any updates that might be required. One common example we refer to is the iRobot and the Roomba, with constant or consistent software updates being pushed out, for example. That customer use information can be accessed by research and development so they can design the next generation of hardware and software combinations. Once design updates are made, you then need to accelerate production simulation scenarios and ultimately push these updates to production so that the next revision or generation is released faster. This then results in customers obviously receiving that updated product and an improved experience faster. And at the same time, throughout this flywheel, it's important to note that the arrows are all two ways. So for example, that production data related to manufacturability or quality, for example, can also be seen in research and development and incorporated in design updates as well. Now, while data is an enabler and drives continuous improvement, it needs to do so with purpose. And so here we overlay the opportunities that data presents with a prioritized list of challenges that industrial manufacturers are facing. In a factory, OEE, or overall equipment effectiveness, is machine availability times performance times quality. And we'll touch on OEE a few times throughout today's session. But really, increasing any of those variables increases OEE. And world-class, we find is somewhere around 85%, although it's very common that when manufacturers start measuring OEE accurately, the number is much lower. The goal is to get to a truthful number and a truthful view of OEE and the underlying components, that availability, performance, and quality, in order to drive a prioritized list of improvement actions that will then make a measurable impact. The result of higher OEE is ultimately improved capacity utilization, or trying to achieve higher throughput at a lower operating cost. Additionally, regardless of product complexity, a manufacturer's supply chain and how material moves into, through, and out of the factories is critical to their operations. And many manufacturers have surprisingly limited visibility into their supply chain, which impacts inventory carrying costs and working capital, production quality, and ultimately delivery performance. Another challenge is that as the workforce continues to transition, manufacturers need to capture the knowledge of retiring workers and automate processes beyond where they are today. Manufacturers also need to make their operation more appealing to younger workers, draw new talent that combines subject matter expertise with some of these newer skills around IoT, machine learning, artificial intelligence, and cloud. And then a central challenge is with a focus on security. And really, we've seen an increased focus on security in factories. It's really never been more important than it is today, since attacks on operational infrastructure continue to increase. One stat that we've had is from 2018, where 30% of security professionals said their organization have already experienced some type of cyber attack on operations infrastructure. This means manufacturers are faced with not only needing to focus on improving their business operations, but also maintaining a secure environment. Another challenge is that on average, factory assets are typically over 20 years old, and much of the production data produced is then trapped in these aging machines. So as a result, many Industry 4.0 or smart factory projects are brownfield in nature and have the added challenge of needing to extract that data from older equipment, enrich it from other sources, and then still drive value with new insights. And finally, reducing costs is a consistent challenge. From reducing energy consumption to improving worker efficiency to minimizing waste, manufacturers need to relentlessly focus on reducing costs to remain competitive and maximize profitability. Additionally, manufacturers also need to focus on moving fixed costs to variable costs in order to improve agility and their ability to flex the cost model relative to demand. Now, these challenges in industrial manufacturing are amplified by the fact that they typically extend across a number of manufacturing functional areas, which we've laid out here on the slide. An output from one process is an input to another. And so as we start thinking about smart factory solutions, we need to ensure the solution fits within the broader system and data flow. It needs to be designed so that it can scale across a global footprint of plants and leverage data throughout this value chain and throughout these functional areas. And so this need for scale and accessibility is really why cloud is a primary driver of Industry 4.0 and digital transformation. Regardless of the Industry 4.0 technologies that you're looking to adopt, cloud quickly moves to the center of your strategy. To manage this increasing volume of data efficiently across the value chain and global footprint, and make the data available for these technologies, such as machine learning analysis, simulation and HPC, augmented reality, etc., having a well-defined cloud strategy is required. On-premises approaches simply don't provide the scalability, security, and reliability required to execute on the breadth of Industry 4.0 use cases. And so now let's talk specifically about how the cloud enables the smart factory. First, as manufacturers look to modernize or transform their operations and their applications, they oftentimes begin their journey with assessing cloud migration opportunities. Many, if not most, manufacturers actually operate in a hybrid environment where some workloads are done on the cloud and some on premises. But what are the drivers or factors you should consider when you think about which workloads you could migrate to the cloud, or how to prioritize based on what will give you the most benefit? Well, from an IT perspective, which we see on the left side here, migrations are often prioritized based on compelling events, such as cost objective, target dates to exit and consolidate data centers, or end-of-life hardware and software. Additionally, improving security and operational resilience is a key driver. So as stated earlier, this is increasingly a challenge for manufacturers. And by partnering with a cloud provider that has a proven track record of maintaining a secure environment, manufacturers can focus less on security and more on running their business. But increasingly too, the conversation is changing now, where there are business drivers that manufacturers need to consider in cloud migration, in adopting cloud migration to satisfy modern operating requirements and enable many of these Industry 4.0 use cases. So for example, how can cloud play a role in accelerating a transformation of the customer experiences using digital thread that extends from product design through production through use in the field? How can the cloud impact your ability to scale solutions globally and align operating strategy across a manufacturing footprint that sometimes is assembled through a number of M&A activities or history? And then a lot of the other business drivers revolve around delivering digital transformations, which can include modernizing legacy SCADA or historian systems, or reinvesting cost savings to drive new innovations and business models that can include scaling technologies like IoT, AI/ML, and digital twins for additional business value. So an example here, let's consider that driver of creating a digital thread that extends from product design through production through use in the field. Many industrial manufacturers are increasingly looking to accomplish this by modernizing their product lifecycle management, or PLM, system. But it's often difficult to achieve a modern PLM on a traditional infrastructure that is inflexible and poorly utilized. So manufacturers find that a modern PLM oftentimes requires a modern infrastructure that is flexible, scalable, available everywhere, secure, and cost optimized. With this combination of modern PLM on a modern infrastructure, manufacturers then have the foundation set to now excel in some of the use cases that are of interest, like deploying smart factory use cases that leverage that product data, machine learning and AI, concurrent design, and digital thread use cases or initiatives. So as we dial now into the infrastructure in the plant, we oftentimes start with the traditional ISO 95 model. Now, in most cases today, the model is defined by monolithic large applications that have been developed to solve one aspect of manufacturing without necessarily taking into account other functionality and integration. This gives us a lot of data that is locked in different systems or silos and can then be hard to pull out and reuse in other contexts. These applications were typically not developed with ease of integration in mind, and so we see poor communication capabilities, a variety of protocols, and in some cases, old proprietary systems. There we go. With newer manufacturing techniques, though, cloud is becoming a more integral part of the stack. For example, moving PLM, ERP, MES systems to the cloud simplifies and streamlines a lot of the tasks around and between these systems. We also see deeper integration between applications, so manual work and transactions can then be automated. Additionally, we have solutions available for flexible shop floor connectivity and descriptive protocols to support the IT/OT transition. But while starting this move to the cloud has many initial benefits, there still remains this green line you see on the screen. There remains this IT/OT divide. And in some cases, there are still complex integrations with legacy systems or data sets. And so the goal that we're working towards is shown here on the right side. It's a cloud-enabled architecture that provides you the flexibility to choose the best system or node here for your requirements with seamless integration into an underlying cloud platform. And that underlying cloud platform is then what provides the data accessibility, security, and scale you need to be successful. So this model then blows away that traditional IT/OT border. That green line has gone away on the screen, and it now becomes the catalyst for data-driven smart manufacturing. So what solutions are available to help you accelerate this journey to that future state? Well, we start first by addressing the data silo dilemma. And what's happened over the last number of years is as manufacturers have developed within that traditional ISA 95 model, and then look to augment with data from quote unquote new sources like IoT or smart machines, a lot of the data lives in these different silos. And so then it becomes really hard to do analytics and scale solutions when you have to go to all those different data silos or different points to aggregate the data. And so to be more direct, the typical challenges that we hear from manufacturers relative to data silos are first managing the OT data and costs. It becomes difficult to scale historians, SCADA, and PLC data for analytics. There's also a high total cost of ownership for some of these on-premises systems. Second is combining that OT and the IT data for use in the analytics. So oftentimes this requires manual data normalization across disparate systems and protocols. Data is also not easily accessible across data owners and organizations to be used at scale. Third, oftentimes reports and dashboards still require a significant amount of manual work to create, and they aren't really enough to then be driving the next level of improvement. When you start to experiment with advanced analytics or machine learning, for example, the insights still require manual intervention for action. You can't push the insights back into the source or the execution systems and then automate the action to realize a faster ROI if you still exist in these different data silos. Plus, the process developed for one plant is oftentimes then difficult to scale or repeat in other plants where the tag structure, the control system, the protocols, et cetera, may not be the same. And so that's what makes it difficult to scale globally. And so to address these challenges, manufacturers are really looking for a highly scalable, available, secure, and flexible data store, or a data lake, that can handle extremely large data sets. And so that's really what we're going to move to. And with a data lake, manufacturers can store all their structured and unstructured data using the open data format of their choice and tag their data in a central searchable catalog. Manufacturers can run any type of analytics, from historical reporting to ML-based predictive analytics efficiently without having to transform or move large amounts of the data. So here are the objectives and the new capabilities that we hear manufacturers wanting to achieve is first to implement a fully managed system that scales efficiently for any data source and any volume data or future volume of data. Second is to create a data catalog with flexible data models. So you want to be able to maintain your source data model, extract and load to a data catalog, transform that data, federate, and query to ensure a single and secure data repository for machine learning. And third is to achieve automated action workflows. This is where you have a closed loop data flow and you can land the ML or the advanced analytic insights directly in a workflow for execution or for action. This also gives you the capability to record what happened for future use in developing prescriptive insights for the next time that you see that failure or that instance. So in order to apply data lakes to address specific smart factory use cases, an industrial data platform has 4 key pillars. We start on the bottom and work our way up. It's the collect, store, analyze, and act layer. Now, let's start at that top act layer and work our way back down the technology stack. So the reason we start at the act layer is it's important to start with the end in mind. What are the use cases that you want to deploy, and what is the value that you want to drive? And so this is where we would have individual applications or solutions that are going to deliver that business value directly. So you might have asset performance management here. You might have a use case around production optimization, for example. But any of these applications or solutions are going to require analytics in order to get the most value. And so that's then where they leverage that blue analyze box. And it's important here to have a breadth of analytics tools available to you so that you can choose the right tool for the job and be most efficient about how you ultimately get to that insight. Now, any analytic is going to require a significant amount of data. And so where do you put that data? That's the green store layer. It's how you store the data securely and in a way that's organized so that you can then scale it efficiently across that global footprint. And then finally, to get that data into the storage, you ultimately need a breadth of services to collect data, whether it be structured, semi-structured, or unstructured, and whether it be coming from an on-premises or a cloud system. And so again, having a breadth of solutions or services that allows you to pick the right tool for the job is important at that collect layer. So next, we'll start at this base collect layer and show different aspects of our solution portfolio that can help you accelerate development of the industrial data platform and deployment of the prioritized use cases on the top of that previous slide. But first, why solutions and what role do they play in the smart factory? Well, our approach is to identify and prioritize the specific business challenges and KPIs that matter most to your operations. Basically, those orange boxes on the top of that industrial data platform overview, and then answer those with a targeted solution. But as we develop these solutions for scale, it's important to note how they tie back to that industrial data platform, as this is critical for scale and prevents you from needing to reinvent the wheel every time you're ready to move on to the next challenge or implement the next solution. And so we start on the left here of this slide with solutions that focus on liberating data and getting that data organized so there is a single source of truth. Then we move forward with use case specific solutions like applying machine learning and AI to improve productivity. And as the program matures, we continuously look for ways to improve, reducing decision latency and taking advantage of new technologies as they become available. So let's start at that collect layer. Looking to liberate production data, we have a breadth of solution services and partners that can help accelerate data ingestion from both IT and OT sources. So again, whether the data is structured, semi-structured, or unstructured, whether it's coming from on-premises or cloud-native sources, we have a breadth of solutions that can help you get connected to it. And we also want to be able to do that in a way where you can maintain the data lineage and the source identity of where that data is coming from. Now, one example is our industrial machine connectivity quick start that has an integrated solution with a number of partners. And here I show an example of integration with inductive automation and Cirrus Link. Essentially, with this solution, if you have an ignition gateway, then you can start building data models and assets in AWS cloud services very quickly with limited coding or AWS services or cloud expertise. So a core component of this solution is what you see in the middle, the Sparkplug Sitewise bridge. The Sparkplug Sitewise bridge accomplishes a number of things. First, it leverages native Sparkplug binary messaging for bandwidth efficiency. Then it consumes MQTT Sparkplug messages, such as data models, assets, and tags. It auto-creates the data model in AWS IoT Sitewise based on the Ignition UDT definitions. And then it can auto-create the asset model, auto-discover the assets, and auto-define the asset hierarchy in Sitewise based on, again, the Ignition UDT instances. Finally, the Sparkplug Sitewise bridge pushes the data into AWS IoT Sitewise time series DB, including property values and timestamps. So as a result now, with an ignition gateway in this solution, you can accelerate connectivity to your brownfield assets establish the data mile and the asset hierarchy in the cloud, and lay the foundation for future innovation with the machine data. Now, let's move to the store layer. We mentioned data lakes earlier, and the traditional approach to building a data lake is actually fairly manual and tedious. In fact, about 80% of the work is typically around data preparation. Plus, the traditional approach presents a number of additional challenges. First, you have to manage and monitor the ETL jobs. You have to update metadata catalogs, and as you have to do those updates as data changes over time. Then you have to update policies across services as users and permissions change, manually maintain cleansing scripts, and finally create audit processes to ensure compliance. So there needs to be a more simple approach or a better way to form data lakes and to do so more quickly and at scale. So for that, we have the AWS Lake Formation Solution Stack, which simplifies the overall process. First, you start with a cost-effective, durable storage using Amazon S3. This also enables global replication capabilities and is tiered for cost efficiency. Then there are a number of tools and services that simplify the data ingestion and the cleansing process, which allows your data engineers or data scientists to do the data science work that drives value. Lake Formation also helps you to centralize permissions and security management so you can manage who has access to the data and manage the overall security of the data in the data lake. And then finally, there are a breadth of analytic tools and integrations that are available to enable users to easily conduct data discovery and start innovating on some of those use cases that we mentioned earlier. Now, once we have the data established in a central repository, we can start accelerating deployment of individual use cases based on a prioritized list of what will deliver the most business value. So this is that ACT layer of the industrial data platform that we spoke to earlier. One place to start is looking at traditional processes that can be modernized and improved with greater accessibility to data. So one such example that we talk about oftentimes, and actually came out of our Amazon fulfillment centers, is the and-on process. So let's start by looking at the traditional and-on process. Whenever an issue occurs on the production line, the operator is empowered to, quote unquote, pull the and-on cord and activate a signal for help. Now, once that and-on cord is seen, a team leader or a supervisor or a technician will oftentimes go to the line and begin their investigation. And so they begin their investigation, and oftentimes the place that they start is just asking open-ended questions to the operator. What's up? What's the issue? And after that initiation or investigation, they'll then call out the right engineer to come fix the problem. Now, there are many merits to this traditional and-on approach in that it empowers the employee to stop the line when they see an issue, and it eventually calls the right people to the line to go correct the issue. But how can we use data and the cloud to make this process more efficient, faster, and better? So if we have a look at what this looks like using the Amazon Virtual and-on solution, what's key here is that the availability of the data allows the plant to resolve that issue much faster and ask better questions, as well as automating the corrective action. So if we start here in this case, the operator would identify the issue on the line. They might do this in real time or via an insight that they saw on an OE dashboard, for example. But as they activate the and-on, instead of pulling the cord, they would use the Amazon Virtual and-on client to do that. Now, because the issue is also backed up with data from the insight and current line performance, when the team leader or the supervisor reviews the and-on call, they already have an idea of what the issue is. And since they already have that idea, they don't need to go to the line and ask some of those open-ended questions. They can already start acting on improving the problem. And in fact, a notification can also be sent directly to the appropriate engineer or technician to get the issue resolved at the line directly. And so the end result is that this solution supports the plant in resolving the downtimes faster. One impact of that is then improving OEE, because you're going to get the line back up and running again. But additionally, as the process is connected, data from the issue is collected and saved for future use in driving root cause analysis or as contextual data for future predictive and prescriptive machine learning models. So again, here an example of where we can take a traditional process, a traditional continuous improvement implementation oftentimes, and now accelerate that in the cloud using data to make it better and more efficient. Now, while we used the Amazon Virtual Andon, or showed that here's an example to contribute to OEE improvement, we oftentimes see use cases that center around how do we apply advanced analytics, machine learning, or AI to improve OEE. So what's key here is as we look at these solutions, it's important to identify analytic solutions that provide visibility into all three of the underlying components of OEE in order to drive improvement actions, those being availability, performance, and quality. And so across all three of these components, we want to use data to drive an improvement strategy that results in cost-optimized performance. This isn't just about predictive maintenance. It isn't just about defect detection. These are use cases in their own right, but it's important to have an overarching strategy for how these individual use cases are going to roll up to improving machine availability, performance, or quality, and ultimately OEE, so that we can measure the impact it makes on the plant operating model. Now, if we double click on availability, and let's just look at how we would go improve availability through using data to improve our maintenance strategy. One question that we often get is, what do I need to get started? Or more precisely, how much data do I need to get started? So here we show a progression of increasing data requirements for a data-driven maintenance strategy on what we just label as a maintenance maturity curve. So many manufacturers are mostly doing preventive maintenance or even reactive maintenance work. They'd be on the far left side here. Here, the typical data required is OEM provided guidance for time-based or cycle-based maintenance tasks. You may also be leveraging an experienced technician or a subject matter expert as a quote-unquote machine whisperer, given their familiarity with the equipment. Preventive maintenance can be enhanced with additional historical data to demonstrate which preventive tasks are most impactful to the reliability of the machine. And then those tasks really are the ones that need to be completed. So for example, an OEM may tell you to change the oil in your car every 3,000 miles. But based on additional data or just your own experience, you know you may be able to get away with changing that oil every 5,000 miles. So how can we add data to this step of the process so that you can be most efficient with that preventive maintenance window? Now, as you connect machines and reference sensor data within the machine or the process, you can also enable condition-based monitoring or rules-based maintenance. This is that next phase. You are collecting data in real time, in this case, and measuring it against a threshold value. And based on predefined rules, are alerting when the measure value trends above or below that threshold. Common data points here or inputs might be temperature, vibration, or a fluid level. The next step then is to enable predictive and or prescriptive maintenance, where additional historical data and system data is needed to make predictions from multiple variables within an operating context. So typically, higher frequency data is required here to build, train, and execute the machine learning model that predicts a failure. For example, on a stamping press, a predictive model may require fine grain tonnage data, so high frequency readings of the force used to complete a press. It may also require bearing temperature and production order detail to know what material is being run through the line at that time, its thickness, its hardness, what impact that has on the process, for example. So to make the predictive insight prescriptive then, historical maintenance work order data is also required. And this really is what is used to match a current predictive failure with similar failures that we may have seen previously. And with this match then, a repair recommendation can also be made automatically based on the maintenance task completed to resolve the previous failures. But I think it's important to note here that as you move into this predict and prescribe bucket, there is significantly more data that's required. And so this is why we oftentimes work with manufacturers around, let's start with where you're at. Let's start with the data that you have available to you. Start in that monitor, prevent, or condition-based phase, and then start accumulating some of that historical data and some of those maintenance records so that we can then enable models in predict and prescribe where they'll have the most value. And then finally, to achieve a cost-optimized strategy, you'll need to add cost data to the models. in order to optimize the cost of performing a given maintenance task against that risk of failure or incurring a planned or unplanned production downtime. And so that's ultimately what we see in the last phase here. And what's key, though, is identifying a solution that can accelerate your time to value based on that known failure mode or your machine type or your process. In particular with maintenance, it's important to work with a partner who has experience or has subject matter expertise in your machine or process, because they'll then have knowledge of some of these common failure modes. Now at AWS, we can support you in developing this with our analytics tools or with SageMaker, but there are also partner solutions that can help you get started quickly. So one example of that is for many discrete manufacturing processes, our partner Machine Metrics provides an out-of-the-box solution for edge connectivity to your machines. They also have an IoT platform that can aggregate the data and run the analytics. And then finally, an application layer that provides visualization and manages the notifications that can be used to accelerate the reaction time for the identified problems. So this is a great partner solution that we work with, again, in many discrete manufacturing applications. Similarly, we have a partner, Seek, that focuses on process manufacturing use cases, and they have built-in connectors to common data sources that you see here on the bottom of the screen. They then have applications applications that help drive the analytics and give you visualizations of those analytics. And you also have the ability to visualize not only then in their application, but integrate into a number of common business intelligence or BI tools shown there on the right side. So with both of these partner solutions, again, the key is that the partners bring the subject matter expertise for certain verticals, manufacturing processes, or machine types. And this is really what allows them to help you accelerate time to value with pre-configured models for common failure modes on these specific machine types, and help you prioritize where to begin and where to get started. So, like I said, these are just two examples of partners where you can partner for expertise within the AWS partner network, where we have established integrated solutions with not only edge hardware vendors, but also ISV vendors or applications that can help accelerate that time to value. Now, in addition to those partners on the left side, we also partner with system integrators and consulting partners that you can work with to help support configuring your environment, deploying cloud-based solutions, and overall with your Industry 4.0 or smart manufacturing strategy. Now, what are some simple steps for how you can get started? Well, in addition to the motivators or the cloud drivers that we covered earlier, we find manufacturers experience a number of benefits as they move to the cloud and begin a cloud-based approach to Industry 4.0 solutions. First, we find that they reduce operation technology and IoT infrastructure costs. So we've seen in some cases that there's over a 50% reduction in IT/OT infrastructure costs. Second is improved IT/OT staff efficiency by moving to managed cloud services. In this case, with managed cloud services, we've seen some customers achieve over a 60% increase in IT staff productivity. Third is improving operational resilience. In fact, operational resilience is in the DNA of cloud. It's in our DNA to help enable high durability and reliability and support critical workloads and critical data. And finally, the ability to implement manufacturing use cases more quickly and to optimize operations and supply chain in a way that you can scale and scale successfully is another key benefit that a lot of manufacturers realize as they start to begin their innovation with cloud-based solutions. And so how do you get started? Or what are some quick and easy ways to get started? First is you can schedule a discovery workshop with AWS Professional Services or with an SI partner. You can engage with one of our marketplace partners who offers a SaaS-based solution or can offer a proof of concept and get you started quickly on your journey. Or leverage one of the open source quick starts that can help you connect to your data and start testing AWS machine learning services. Either way, whichever path you choose, AWS is here to help. And we would look forward to engaging with you on your prioritized list of use cases and helping you accelerate that adoption. Again, be it with one of our SI partners, one of our SaaS partners, or through working with you on building a custom solution using our services. And so with that, Kevin, I'll move to Q&A and see if we have any questions in the box.
Yes, thanks, Joe. Cloud certainly has transformed the applications landscape in manufacturing, and I want to thank you for that comprehensive presentation about what's happening in manufacturing enterprises today. Joe will now answer questions from the audience. Type your questions for him in the Ask a Question box on your screen. We'll get to as many questions as time allows. Questions that we don't get to today will be posted online with the archived version of this webcast. Remember to download a certificate of completion, a copy of the presentation, and other resources. Use the Event Resources tab on the left-hand side of your screen. Now, Joe, one of our attendees has asked a question as follows. You mentioned security a couple of times. I can see how cloud makes deployment of these solutions faster, but how do you manage data security in the cloud?
Yeah, that's a great question and one that we hear often from manufacturers. So AWS already meets the high standards for security-sensitive organizations such as government, healthcare, financial services. And so, for example, when we reviewed the AWS Lake Formation solution stack, we saw that we use Amazon S3 for the data store. Well, Amazon S3 is secure by default. If customers use the default configuration, that S3 bucket locks down access to just the account owner and the root administrator. And more than 1 million customers are using Amazon S3 safely and securely today. And so the value of that to you as a manufacturer is not only is your data safe, but again, by partnering with a cloud provider that has this track record of maintaining a secure environment, you're then able to focus more on running your business and driving innovation and don't have to worry about some of that heavy lifting that's involved in making sure that the environment is secure, because that's inherent to the nature of Amazon S3 and the infrastructure that we would provide.
Thanks, Joe. Another of our attendees asks as follows. I'm not going to be able to flip the switch to cloud overnight. How do you support manufacturers who need to keep some or most of their systems on premises as they experiment with cloud and build their strategy?
Yeah, so again, a common question we hear from manufacturers, because we recognize that you're not going to be able to flip the switch and go to cloud overnight, and there's a number of reasons for doing that. So when a manufacturer has some workloads running on premises and some in the cloud, we define this as a hybrid environment. And again, this hybrid environment is absolutely common. So to your point, it can take time. There's a number of complexities that are involved in migrating the cloud. And so we can certainly support with connecting to data that sits on premises and have reference architectures on how to do this. We can also then help you assess which workloads it makes sense to move to the cloud first, based on some of the drivers that we spoke on earlier, such as cost reduction, reliability, et cetera. And then work with you on how to mitigate any risks associated with those migrations. But all the while, again, we have reference architectures of how we would work in this hybrid environment. So even as we would move or migrate some of those systems to the cloud, we can continue to work in that hybrid nature in order to make sure we get all that data that you need for those use cases back into that central repository and be able to use it efficiently for some of those machine learning applications or smart factory use cases.
Thanks, Joe. An attendee asks, we don't really have coders. My engineers can do some analysis in Excel or with other tools, but we're going to struggle with doing a lot of integrations of systems and building solutions. What should we do next, or how could we get started?
Yeah, again, this is a common question. And in fact, most manufacturers are working to implement smart factory or Industry 4.0 solutions with process or manufacturing engineers. They're oftentimes in a manufacturing plant, we don't have software developers, for example, right, that can custom code solutions. So really, there are 3 ways to get started. First is, again, if you reference, for example, the AWS Partner Network, where we have SaaS applications these applications can support you in buying a solution versus having to build it. And our partners are great at helping you get up and running quickly on their application. And then once you've started with that initial POC, being able to extend it into other failure modes, for example, or other applications using their analytics, so that you can meet the needs of your future roadmap still, but leverage the expertise of the partner in that SaaS application. The second option is working with our professional services team or a system integrator or even a consulting partner can augment your team's subject matter expertise with the development and the cloud skills to help you get started quickly. And then third would be our solutions that we have available are really designed to be accelerators. And we continuously are working to simplify these solutions and make them easier to use. So for example, the connectivity solution that I mentioned earlier, where you can use an ignition gateway that then requires little to no coding to ultimately get started and get data off that ignition gateway and into an IoT service on the cloud. If you engage with these solutions, many of which are available open source, we're certainly happy to help you get started on your journey and help assist you as you start to deploy those in your specific environment.
Thanks, Joe. So we've got time for about 2 more questions. Regarding the OEE solutions, you talked about availability, performance, and quality. Of those 3, where do you see most manufacturers getting started and driving the most value?
Yeah, well, usually what I suggest is the place to start is where you have the biggest need. And again, that's why I like to break OEE down into these sub-3 metrics as availability, performance, and quality, because then that really clearly sets the stage for where you have the most opportunity to improve. And then you can start to align some pretty direct projects or actions to improve one of those 3 individual components versus trying to boil the sometimes nebulous OEE number or percentage in and of itself. Now, I'd say many manufacturers start with maintenance because doing a POC in maintenance is relatively straightforward, especially for common machine types. Oftentimes, you can get an initial feel for how it's going to work with somewhat limited data, and so it's a little bit easier to get started. But as manufacturers become more comfortable with the analytics, we also see a lot of value being driven from quality use cases. Using analytics to improve defect detection and ultimately predict quality defects prior to an end-of-line test and drive up that quality number that impacts OEE, but also just drive overall improved throughput yield. But I think the important thing is, regardless of which of those 3 components you would start with, some advice would be start small with the data that you have, and then look to strategically be adding data inputs, strategically be adding use cases or failure modes to drive that additional value. But certainly start small to start to get a feel for the insights that are possible, how you land those in workflow, and then how you can take action on them to start getting to that point of value.
Yeah, thanks, Joe. And as we move to the final question, I certainly want to thank our attendees for their insightful questions. The final question is, when you reviewed the industrial data platform, there was a box in the ACT layer for supply chain management. What type supply chain use cases or solutions are you seeing that are creating value for manufacturers?
Yeah, great question. And, we really kept the focus here on smart factory, what I would consider use cases inside the 4 walls of the plant. But supply chain management certainly has a significant impact on operations on the plant. How material moves into, through, and out of the facility is critical and often plays a critical role in terms of how you're able to utilize capacity and be successful. So a couple of the solutions or use cases that we hear commonly, I would say especially in the last 6 to 9 months, revolve a lot around demand planning. So, as economic conditions have been what they are over the last several months, we found a lot of manufacturers that have actually turned off APO or turned off some of their formal forecasting processes and started asking us, what different tools can we use to drive better forecasts and better demand planning. And so we started to work with customers on how can we implement machine learning to improve forecast accuracy. And really that becomes a key input then in terms of pushing a more accurate forecast into the plants that allows for improved production scheduling, improved inventory optimization, and then ultimately improved delivery performance. So I'd say that's a fairly common use case that's getting a lot of attention recently, as well as some others around using IoT capabilities for doing track and trace, for example, is another common one that comes up around supply chain. But I would say certainly that demand planning aspect, can be a key source of variation that is important to have mechanisms for how you can control or address that demand variation to drive better performance in the manufacturing plant.
Well, thanks, Joe, so much for taking the time to share your expertise and knowledge, and I want to thank our audience once again for the great questions. I'd also like to extend special thanks to our sponsor, Amazon Web Services, for sponsoring today's event. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Plant Engineering and Amazon Web Services, I'd like to thank you for attending. That concludes our webcast. We'll see you next time.